Hello, in this video we're going to look at some insurance proofs or results. U subscript 0 is the expected utility if uninsured. U subscript 1 will be the person's expected utility if that person has full coverage insurance. Full coverage insurance pays the size of the loss, L, if a loss occurs. P will equal the probability of loss. H will represent the insurance premium, what the person pays for the insurance policy. And so the expected utility if uninsured will look like this. Again, P is the probability of a loss. If a loss occurs, your utility will be equal to your wealth, W minus L, the size of the loss. 1 minus P means the loss doesn't occur. It's a probability that the loss doesn't occur. And in that case, your utility will just be equal to your wealth. With insurance, the probability of loss, your utility will look like the following. You'll have your wealth. You'll pay an insurance premium. You'll experience a loss, but because of the insurance and it's full coverage insurance, you'll be compensated for your loss. And then the probability of not having a loss, you'll have your wealth, and you will just lose your insurance premium. That'll be subtracted from your wealth, the minus H. This will just simplify down to the following. To purchase insurance for an expected utility maximizer, it must be true that the expected utility with insurance is greater than the expected utility without insurance. So result 1, the utility of purchasing insurance falls as the insurance premium rises. So the expected utility with insurance is given as follows. Taking the derivative or partial derivative of that with respect to the insurance premium, it's going to be negative. So that indicates that purchasing insurance falls as the utility of purchasing insurance falls as the insurance premium rises. The sign on the partial derivative here is negative. Result 2, the maximum premium, H star, a person is willing to pay for insurance is given by the following. That is a utility with insurance. The expected utility with insurance equals the expected utility without insurance. So in other words, we can define H star as the following. The left-hand side again is the expected utility with insurance. And that will just equal your expected utility without insurance at some maximum value for the insurance premium that this person is willing to pay. All right, result 3, the maximum willingness to pay for insurance is less than the size of the loss. So our result from before. And the utility here of wealth minus your maximum willingness to pay is just a weighted average of the right-hand side here. And so we can write it like this. Result 4, the maximum willingness to pay for insurance increases with the probability of loss. So let's just take the total differential of that. Let me get this result on the left-hand side. The minus is from taking the partial derivative of minus H star. So we just get minus 1, or just minus. And then on the right-hand side, we will get this result. Derivative of P here is just 1. So the total differential here, we're just going to have change in P or dP here. The derivative of minus P is minus 1, so that's where this minus is coming from. And so we get the change in probability of loss over here, dP. Factoring out the dP term here on the right-hand side, and then just rearranging, we'll get this result. The numerator will be negative. The utility of wealth will exceed the utility of wealth minus the loss. So we're going to get a negative sign in the numerator. And since the marginal utility is positive, we got a minus marginal utility. The denominator will be negative. So negative, negative. This result sign on this derivative here will be greater than 0. So indeed, the premium increases with the probability of loss. And the next thing we want to show that the maximum willingness to pay for insurance, the premium, increases with the size of the loss. The last result was the probability of the loss. This time it is the size of the loss. And a similar setup, going to take a total differential. So here we're going to look at the right-hand side, and we have a minus L here, so the derivative of that is just minus 1. So that's where this minus is coming from. And then we got dl. Rearranging, we get this result. The minuses and minuses cancel. This is greater than 0. Okay, that's it. I hope you found this video helpful.